the x. So you take that 2 and you plug it in where the x was within the original equation. Gives you positive 6 minus 5y is equal to 16. Solving from here is as simple as subtracting your constant and dividing by your coefficient. So you should have a value of y equaling -2. To check yourself, you could simply plug it back in right here. So 6 minus 5 times a -2, does that indeed equal 16? 6 plus 10, and you know you're correct. And the -5 times the -2 became positive there. They don't ask you to graph for 1, 3, and 5. Number 3 has a fraction. We'll do that one. It's not any more difficult, just a little bit more thinking. 6x added to 3y is equal to -5, and they tell me that x is a -3rd. X is a -3rd. So that means plug in the value for x. 6 times blah blah 3y. Right over here. -1/3. So -1/3 times 6 is what? -2? Huh? Yeah, -2. Add 2. What'd you get, a -3 there? So y is equal to -1. Based on all of that, we believe y equals -1. So -2 added to 3 times -1. Yeah, you could pretty well see that that's true. You guys okay so far? Yep. 7x is 0. 5x is 0, and I am going to do this one for you only because I fear that you might make a sign problem or a sign mistake. So x is 0, so -4 multiplied by 0 minus y is 8. So that becomes a 0, means -y is 8. I don't want to know what -y is, I want to know what y is. What is it? -8. Y is -8. So -8 does equal 8? Why, yes, it does. Seven, find a value for k so that the pair given will satisfy the equation. So you're basically solving for the variable k. So they gave me 0 and -2. 2 times 0 minus k times -2. So it almost looks to me like it becomes positive. 2k equals 6, so k is what? 3? K has to be 3. Which means the equation could say 2x minus 3y. Plug it in right there. Okay? That'll help you with number 8. Name the quadrants of the point described. Goodness gracious. 9 through 15. If you're not sure on how to do these, I'll show you really quick. So in quadrant 1, it's positive, positive, right up. In quadrant 2, it's negative, positive, right, left, up. In quadrant 3, it's negative, negative. And in quadrant 4, it's positive, negative. So the value of the x is the first one, the value of the y is the second one. The value of the x, the value of the y. The value of the x, the value of the y. X, y. So if both coordinates are negative, where will they be? Yep. The coordinates are the same. Close. Coordinate 3, quadrant 3 or quadrant 1. So like take for example 2, 2. That would be here. Just like negative 2 would be here. So there's your answer for 11. Well, I would put them both, even though it says name the quadrant. Put both. Number 11, the coordinates are the same. Number 13, the coordinates are opposite. So negative 2, 2, or 2, negative 2. So those are going to be quadrants 2 and 4, aren't they? And if y is negative 1, so any x, 3 and 4. Very good. Excellent. Number 17 is the last one we're going to do. I love it when they give you multiples, or I'm sorry, factors for the C value. So I can easily just do a quick XY table. If X is 0, what must Y be? What do you think?
3.
Yep. What if Y is 0, what's X?
4.
Yep. Very good. So I'm not sure what the you know what, I'm just gonna go this way. I think this will work. I'm sort of trying to guess on what the other graph's gonna look like, because you can graph them both on the same coordinate plane. So I'm kind of going a little bit off to that direction there. So over 0, up 3, and over 4, up 0. Your first graph looks like that. Whenever you graph multiple graphs on a given plane, I like to label which graph is which with its equation. That's one of the ways I like to do it. Okay? So 18 you can obviously graph on here as well, like it says. Graph it on there.